The next delivery of cargo to the International Space Station is due on a Dragon spacecraft that is targeted to launch on March 16th. That will contain a lot of experiments that are going to do their work inside the station, and one big experiment that will be doing its work on the outside of the station. The high-definition Earth viewing experiment is part of the next Dragon payload, and the HDEV lead engineer, Lori Moats, is with us this morning to talk about that. You're flying 4 high-definition cameras. What's the story behind all of that? Tell me where they go and things like that.
That's right. We're flying 4 different commercial high-definition video cameras, and our team designed the enclosure and the avionics to integrate the experiment on orbit. We'll be flying in the SpaceX Dragon trunk. That's their exposed facility, and we're the first exposed payload and the first powered payload that SpaceX is flying. So it's been exciting to be integrated with them as they've gone through those challenges.
That's you in the back of the...
Yes, this is a picture of us integrated in the SpaceX trunk as they've gone through some of our challenges. That's our enclosure, and you can see several pockets on either side of the camera where the windows where the cameras peek out.
We had a close-up view of the payload itself. If you could describe for us it's a big box that has the cameras inside it, I guess.
That's correct. That's correct.
The inelegant way.
Since we, no, that's a pretty easy way to describe it. We have, so you can see on the bottom right picture, there's 2 windows, and then on the left-hand side, and then 1 window that you can see on the right-hand side. And when we pick these commercial cameras, they aren't designed for space exposure, so we've kind of protected them from the vacuum and the thermal environments of space with part of our design. And so that's what the box, and you saw the silver covering is for protecting the cameras from that part of the space environment.
And when you get there, where is this apparatus going to end up?
When SpaceX docks on orbit, the robotic arm will remove us from the SpaceX trunk and then take us over to the European Space Agency's Columbus module. And then this is a great picture will be installed on the bottom location that you see there on their external payload facility. There's like 4 different platforms that you can see there, and the bottom platform is the nadir location, is pointing towards Earth. So all 4 of our cameras will be pointed at different angles towards Earth. We have 1 camera that will be pointing forward, so looking where the ISS is traveling. And then we have 1 camera that will be pointing straight down exactly towards Earth, and 2 cameras that will be pointed kind of towards the back, to see where the ISS has been traveling.
And they're all pointing on essentially the same path, so they could track
exactly
where the station is flying.
So if there was a weather event, say like a hurricane, that we wanted to see or track, we could see if the ISS was going over that event, we could watch it as the ISS is approaching, transfer to the camera, then watch it as the ISS is over the event, and then transfer and watch as the ISS passes.
Is the goal here to get a lot of beautiful HD video of the Earth?
No, that's certainly a good side effect, but it's really an experiment. The reason we have 4 different commercial cameras is we want to see not just how these commercial products respond to the radiation environment, the cameras themselves, their sensors, and also the integrated system. The products weren't designed to be exposed to the radiation environment of space, so we want to see how, as we move forward as NASA's partnering with more commercial entities and with as we try to move forward and achieve our goals, we want to see how robust we can be and to make more intelligent decisions as we move forward.
You described earlier that the enclosure is protecting these cameras to some extent, but not completely, I guess.
That's true. Yes. I mean, we still need a more robust design would be to put it in a completely enclosed box, but then you wouldn't get very good video, would you? So it has to be able to see outside. So outside of the space station, you still have the radiation effects, and that's the video sensors are really sensitive, particularly sensitive to radiation exposure. So we're actually partnering with university students, and they'll be looking at recording some pieces of the video data over time from the different cameras, and developing ways to examine how the video is degrading as the cameras are exposed to more and more radiation.
I want to ask you about the student involvement, but there is a way for people to see the video as it's shot, right, or relatively soon.
That's true. One of our kind of key missions here is it's basically live video streaming. The only delay in the system is the delay in downlinking the video from the station to Earth. There is a website that is being set up, Ustream website, where there's the link there that once we're installed and powered, it will be streaming the video essentially 24/7. Down, and so anybody from the public can come and see the video and link to and see just where the station is. Eventually, they want to have kind of a graphic of the world with an image, so you can see, oh, this is where ISS is now, and then you can see the actual video.
And you can see where it's headed.
To correlated to where it's going, yeah. So that's kind of the image. I think the link, if you go to the link now, it's just as video from the NASA website, but it's going to be pretty exciting.
You mentioned students a moment ago. There are students involved in both the preparation and then in the experiment after it arrives.
Yes,
right?
that's true. We've partnered with the University of Houston Clear Lake to they'll be maintaining the website and also operating the payload when it's on orbit. The payload's pretty autonomous, meaning once it's installed on orbit and we turn it on, it just kind of cycles through the 4 different cameras on its own. But we do have the option that if we want to change the order that the cameras cycle or how long we sit on any one camera, they can do that and make that change. And as time progresses, if, say, one camera finally stops working, we can cycle between 3 cameras, and we can make those sorts of changes. And the students would be doing that effort, as well as analyzing the video to see how it's degrading over time. In the actual hardware development itself, we actually involved the HUNCH program, which is high school students united with NASA creating hardware.
Of course it is.
It's the HUNCH program, so it's high school kids that they are coming in with, it's amazing. They're so young, but they're creating hardware, software, and electronics that we actually have brackets. They had some mechanical design, and they actually built hardware that is in our box and about to fly. So it's part of what made us work. So
we'll be looking forward to seeing that.
Yeah.
It ought to be very interesting to see that once it does. The HDEV payload scheduled to fly on the Dragon spacecraft. It's launching on March 16th. Lori Moats, thank you. Lori is the lead engineer for the HDEV payload.